National Electrical Code Article 300.22c states that raceways are not permitted to extend below the bottom of the enclosures on which they are mounted. Also, National Electrical Code Article 300.22e states that raceways are not permitted to be installed below the floor unless approved for underground use. These code provisions do not explicitly address the use of a concrete trench or wireway under a motor control center, referred to as MCC. However, they suggest that raceways should not extend below the bottom of the MCC enclosure and should not be installed below the floor unless approved for underground use. Several alternative solutions exist to accommodate a large number of conduits under an MCC. Firstly, consider a raised platform. This involves installing a raised platform under the MCC, providing space for the conduits to be routed without extending below the bottom of the MCC. Secondly, explore an extended base. This means fabricating an extended base for the MCC that accommodates the conduits without violating the NEC requirements. Thirdly, consider a conduit ladder. A conduit ladder can be installed alongside the MCC to support and route the conduits. Fourthly, a floor tray can be used. This involves using a floor tray to organize and support the conduits under the floor adjacent to the MCC. If installing the conduits in a concrete trench or wireway below the floor is unavoidable, the raceways must be approved for underground use. This typically requires the use of concrete encased conduit or other raceways specifically designed for below-grade installation. The NEC generally does not permit extending raceways below the bottom of the enclosure or below the floor without proper approval. Alternative solutions should be considered to accommodate a large number of conduits while adhering to code requirements. These solutions include raised platforms, extended bases, conduit ladders, and floor trays. Ensure that any underground installations use raceways approved for that purpose. When dealing with motor control centers, or MCCs, and the routing of conduits, several important factors must be taken into consideration to ensure compliance with the National Electrical Code, or NEC, and to maintain safety and efficiency. The NEC provides specific guidelines regarding the installation of raceways, which are enclosed channels designed to hold wires and cables. These guidelines aim to prevent electrical hazards and ensure the integrity of the electrical system. When planning conduit entries into the bottom of an MCC, one must avoid practices that could violate NEC regulations. Article 300.22c specifically addresses the installation of raceways and states that they should not extend below the bottom of the enclosures on which they are mounted. This means that if you are installing conduits to feed into the MCC, the conduit run should not drop below the lowest point of the MCC enclosure itself. This regulation prevents potential physical damage to the conduits and ensures that the enclosure provides adequate protection to the wiring within. Similarly, Article 300.22e states that raceways should not be installed below the floor unless they are approved for underground use. This provision is in place because underground environments can expose conduits to moisture corrosion and physical stress. Using raceways that are not specifically designed for underground use can lead to premature failure and electrical hazards. Therefore, any conduit that is buried or installed beneath the floor must be rated and approved for such applications. The common practice of creating a concrete trench or wireway under the MCC and stubbing conduits up into it is a solution that requires careful consideration. While it may seem practical, particularly for managing a large number of conduits, it can easily violate the NEC if not done properly. If the trench causes the conduits to extend below the bottom of the MCC enclosure, it is non-compliant with Article 300.22c. Similarly, if the trench is below the floor and the conduits are not approved for underground use, it would violate Article 300.22e. To overcome these challenges and still effectively manage a high volume of conduit entries, there are several alternative solutions that can be implemented. Firstly, consider installing a raised platform. A raised platform involves elevating the MCC above the floor, creating a space beneath the unit where conduits can be routed without extending below the bottom of the enclosure. This platform provides a dedicated area for managing conduit runs, making it easier to organize and maintain the wiring. The platform must be structurally sound and capable of supporting the weight of the NEC and its associated equipment. Secondly, explore the option of fabricating an extended base. An extended base is a custom-designed structure that attaches to the bottom of the NEC, effectively increasing its height. This extended base provides additional space for conduit entries without violating the NEC prohibition against conduits extending below the enclosure. The design of the extended base should be carefully engineered to ensure stability and proper alignment with the NEC. Thirdly, utilize a conduit ladder or a cable tray system. Conduit ladders and cable trays are support structures that run alongside the NEC, providing a means to route and support conduits and cables. These systems allow for organized and accessible wiring runs, making it easier to add, remove, or maintain circuits as needed. Conduit ladders and cable trays are particularly useful in industrial settings where frequent changes to the electrical system are common. Fourthly, a floor tray can be used. A floor tray involves installing a tray system at floor level adjacent to the NEC to manage conduit runs. This approach keeps the conduits organized and prevents them from being scattered across the floor. The floor tray must be designed to withstand the weight of the conduits and any potential physical impacts in the area. The selection of materials and construction methods for these alternative solutions should be based on the specific requirements of the installation environment. In corrosive or wet environments, it is essential to use materials that are resistant to corrosion, such as stainless steel or PVC-coated conduit. In areas where physical impacts are likely, heavy-duty conduit and robust support structures should be used to protect the wiring. If, despite these alternatives, it becomes necessary to install conduits in a concrete trench or wireway below the floor, it is imperative to use raceways that are specifically approved for underground use. This typically involves using rigid metal conduit encased in concrete or using direct burial-rated conduits. Concrete encasement provides additional physical protection and helps to prevent corrosion. Direct burial-rated conduits are designed to withstand the harsh conditions of direct contact with soil and moisture. When installing conduits underground, it is also important to follow NEC guidelines regarding burial depth. The depth at which conduits must be buried depends on the type of conduit and the voltage of the wiring within. These requirements are outlined in NEC Table 300.5 and must be adhered to in order to ensure the safety and longevity of the installation. Proper grounding and bonding are also essential aspects of any electrical installation, particularly in industrial environments. Grounding and bonding help to prevent electrical shock hazards and ensure that fault currents can safely return to the source. All metallic components of the electrical system, including conduits, enclosures, and equipment, must be properly grounded and bonded in accordance with NEC Article 250. The grounding and bonding system should be regularly inspected and tested to ensure its effectiveness. In summary, when planning conduit entries into an NEC, it is essential to carefully consider the requirements of the NEC and to implement solutions that comply with these regulations. Avoid practices that could violate Article 300.22c and Article 300.22e. Consider alternative solutions such as raised platforms, extended bases, conduit ladders, and floor trays to manage a high volume of conduit entries while maintaining code compliance. If underground installations are unavoidable, use raceways that are approved for underground use and follow all applicable NEC guidelines regarding burial depth and grounding. By adhering to these principles, you can ensure the safety, reliability, and longevity of the electrical system in your industrial facility. Furthermore, the NEC is not a static document. It is updated every 3 years to reflect changes in technology and best practices. Therefore, it is essential to stay informed of the latest revisions to the code and to ensure that your electrical installations are in compliance with the most current requirements. Consulting with a qualified electrical engineer or licensed electrician is always a good idea when planning complex electrical installations. These professionals can provide valuable guidance and ensure that your project meets all applicable codes and standards. In addition to the NEC, there may be other local or regional codes and regulations that apply to your electrical installation. It is important to research and comply with all applicable codes to avoid potential penalties or safety hazards. Remember that electrical safety is paramount. Always de-energize circuits before working on them and use appropriate personal protective equipment, or PPE, such as gloves, eye protection, and ARC-rated clothing. If you are not qualified to perform electrical work, seek the assistance of a licensed electrician. In conclusion, effectively managing conduit entries into an MCC requires a thorough understanding of the NEC, careful planning, and the implementation of appropriate solutions. By adhering to code requirements and best practices, you can ensure the safety, reliability, and efficiency of your electrical system.